This question is asking, under which conditions does the system have a unique solution, no solution, or infinite solutions? And we're given these 4 different equations. So first, let's convert this into a matrix. So we'll just say that we've got 1 in that column for the x1, then we have a 0 for x2, and then there's going to be 1 for x3, and a 0 for x4. And we'll set that, the augmented matrix, equal to Q here. And then we put a 0, and a 3 here if we want to. And then we could say 0, and then 1, 0, 2, 1, 0, 2, 3, and 0, 2, 3. And this would just be a P. From here, we have to start reducing this. So let's go ahead and subtract from this row here. We're just going to subtract this first. So we're going to go 1 minus 1 times the first row, minus 1 times the first row. And then here we have nothing, and minus 1 times that Q over there. And for this row, we're going to subtract this row. But we're going to do that twice. So minus 2 times that row here. And then there's a 0, but then minus 2 times the 2 that we have here. And then there's another 0. So this should reduce, and it'll come down into a 1, 0, 1, 0, Q, 0, 1, 0, 2, 0. And then we have a 0, and a 0. And this here will just become a 1. And this becomes a 3. And this here is, of course, negative Q. That's a Q. And then over here, this becomes a 0. So we have 0, 0. This is a 3. And this becomes P minus 4. And we have the 3. At this point, let's go ahead and just subtract 3 times this row. So that way we can get a 0 over here. And then we're going to do that right here. 3 times this becomes a 3 there. And then here we can go minus 3 times the negative Q that we have in that row. So this will leave us with a 0. And then here we have P minus 13. And then here we have 3 plus 3Q. And that's kind of what we have in the last row there. Now that last row is really what matters. So we have some zeros here. We're just going to kind of cross out that last row here. So we can see this is the last row. Now here's what I mean. In order to get a unique solution, we need to have an identity matrix here. So we would get 1, 1, 1, and a 1 in here. If we do that, then this last row can cancel everything else out here, and then we'll be left with a nice unique solution. And so we can represent that by saying, as long as we get a question mark equal to B, then we can essentially divide everything by the question mark, and we'll just get 1 equals whatever on the right. Now, the key here is that the question mark cannot equal 0, because if the question mark equals 0, then we get something like 0 equals something on the right over here. And well, we know that that would be no solution because 0 equals something is not going to be right. But as long as that question mark is not equal to 0, because 0 equals 0 is correct, and that would actually give us infinite solutions. So we kind of have this sort of chain effect that we have to check for in order to make sure that we can get some solutions. So let's start with this first one, question mark equals B. We'll try to set up question mark equals B over here. So the right side can be anything. It can even be 0, that's fine. But over here, we just have to make sure this is not 0. Okay, so if P is not 13, if P is 13, then that would be 0, and that would be a problem. But if P is not 13, then, like, let's say it was 14, then you get a 1 right here, and everything is good. And for every other number, you can just divide it out, and then you'll just get this to work out. So this will give you 1 solution. The next part is trying to find 0 equals question mark. So we'd set P minus 13 equals 3 plus 3Q. And then we'd set it up like 0 equals question mark. So 0 equals question mark. This must be 0, so we'll just set P must be 13. But if P is 13, then this over here cannot be equal to 0, because if that's equal to 0, then that just gives us the next answer. If we try to solve this equation for 0 on the right, we'll get Q equals negative 1. And so it cannot equal negative 1. If it was negative 1, then this side becomes 0, and then that wouldn't work. So we have this gives us no solutions. because here we get a 0, and then here we get some numbers, so that sets us up like that. Now for the last one, 0 equals 0, we're going to set that up over here, and we're going to see that we've already sort of done that. That this side, in order to get that equal to 0, P must equal 13. In order to get this side equal to 0, Q must equal -1. And so now we found that this one gives us infinite solutions. And so now we have one solution, no solutions, and infinite solutions.